Okay, we're going to take a look at our second example of the mathematics of. And in this case, we don't have anything as nice and pretty packaged as the last example where we could take 24 and split it into, or partition it into 3 equal groups. In this case, we have 2/5 of 8/7. And we can't take our 8/7 and divide it or partition it into 5 equal groups. So we have to take a look at our other theorem, which is the theorem of equivalent fractions, to force the numerator here to be divided by 5. So let's take a look at that. Remember, we have the length of 0 to 8/7, and we want to partition it into 5 equal lengths. But we can't do that. So what we have to do is we have to force the numerator. So we're going to take 8/7, and we have to partition it into where it can be divided by 5, or split into 5 groups, which means now what we have to do is we need to partition our segments into 5 equal segments. So now that we've done that, we are going to get, now we can get 8 copies, because 8 times 5 can be split up into, divided into 5. Now we can take 5 groups, but it's going to be of 1 over 7 times 5, which is 35. So 1/35. So if you notice, if we count all these up between 0 and 1, there should be 35 partitions. And then we want 2 copies of this. So we want 2 copies of 8/35. Well, 2 copies of 8/35 is just 2 times 8 over 35, which is 16/35. So in order to split the numerator into equal segments, sometimes you have to use the theorem of equivalent fractions, theorem 1, to force that numerator to be able to be partitioned into equal groups. When you do that, remember that you're partitioning, which means you are finding smaller segments, and then you can take that many copies of it. So basically our next theorem, this leads us up to theorem 3. Which says if you have K over L and M over N, then if you want K of L of, so you want a fraction of a fraction, it is basically equal to K times M and L times N. And I think you'll recognize that as the definition of multiplying fractions.